Hi everyone, we are Group 1 for ECG565 from Class 7 B1A. For this project, our study location is the parking zone inside the UiTM campus. This area was selected because parking zones experience frequent low-speed vehicle movement, continuous braking and turning, and repeated exposure to water after rainfall. Depending on pavement texture and drainage condition, water can remain trapped on the surface. Even at low speeds, a pavement that appears normal can become dangerously slippery when wet, particularly in turning and braking zones. So, this leads to the key question of our study. Does this pavement surface provide sufficient friction and effective water removal under both dry and wet conditions? Or are there hidden surface characteristics that increase risk when it rains? At first glance, the surface looks acceptable, but performance is not determined by appearance alone. Now, to answer this, we conducted 3 assessments. First, a skid resistance test performed under both dry and wet conditions to evaluate changes in surface frictions. Second, a sand patch test used to estimate surface microtexture, which affect tire grip and water escape. Third, an outflow test to evaluate how efficiently water is removed from pavement surface. For safety, all tests were conducted in control zone using safety vests and cones, while ensuring our team remain clear of moving vehicle. Let's now begin with the first experiment.
Assalamualaikum, my name is Idlan Danish bin Maisel. Today, I will explain about the skid resistance test. Firstly, we need to wear safety vests and create a safe working zone. We also make sure the tester is placed on the stable ground and nobody stand in front of the swinging arm during the test. Next, for the apparatus, we use British pendulum tester complete with the rubber slider, spirit level to level the equipment, a marker to mark the exact test location on the pavement, a water container to wet the surface for the wet surface test, and a brush to clean any dust or loose particle that could affect the friction reading. Next, for the procedure, we start by selecting a representative pavement spot, then place the British pendulum tester, adjusting the feet and checking the bubble level until the instrument is fully level and stable. Next, we mark the test area clearly using the marker, and we clean the marked area using a brush. After that, we perform a quick calibration check to confirm the pointer is functioning correctly before taking readings. Next, we set the slider and arm height so the rubber slider make proper consistent contact with the pavement. Then we carry out the dry test by releasing the pendulum, allowing it to swing and contact the surface and recording the reading shown on the scale. We repeat the dry test 5 times and take the average value for the wet test. We pour water from the container to wet the same marked area evenly and create a thin water surface. Then we repeat the same step, release, swing and record the reading again 5 times and calculate the average wet skid resistance.
My name is Hafizuddin Samsudin. For this part, I will talk about sand patch method. So, the apparatus that we use in this method is first, standard sand volume container, rubber disc, measuring tape, stopwatch, brush and tray. So, the procedure of this method is first, we measure a fixed volume of sand using the container. Next, we pour the sand into the pavement surface. Then, we spread the sand into the circular motion using the rubber disc until it fills surface void. Then, we measure the diameter of the sand patch in 4 directions. Lastly, we measure and calculate the average of diameter by using the formula.
Hi everyone, my name is Nur Iman bin Ahmad Syamim. I will explain about outflow meter test. So, first, before we start, make sure we wear safety vest as it is very important in this project. The apparatus that we use is first, outflow meter, a squeeze bottle that contain full water, and a stopwatch. So, the procedure is first, at our site selection, clear all the debris first. Then, put the outflow meter flat on the road surface and make sure the outlet valve is closed. Fill the outflow meter with water for 400 milliliter with squeeze bottle. Then before we start, make sure that we start the stopwatch and open the outlet valve simultaneously. Record the time when all water is fully flow out. Repeat the experiment for 3 times, then take the average time. A shorter time means a better surface drainage. Then I will pass to the next person.
Assalamualaikum. My name is Faris bin Muhammad. So I will summarize our results by benchmarking them against the JKR reference values and explaining what they mean for safety and performance. For skid resistance, our average readings are 116.4 in dry and 107.6 in wet. With the JKR benchmark set at 47, both conditions clearly pass, which indicates strong surface friction and better braking stability, especially in wet driving. Next, for the microstructure using the sand patch test, we use with standard sand and calculate structure depth from the measure diameters. The average texture depth is 2.032 mm, which is well above the JKR reference of 0.50 mm, so this is also pass. High structure depth has water escape from the tire road contact, improving driver confidence in rain. However, for the outflow drainage test, our average outflow rate is only 3.16 liter per minute, while the benchmark is 10 liter per minute, so this is a fail. Slow drainage can cause spawning and reduces perceived safety, leading to lower speed and less efficient traffic flow. To improve and achieve pass, we recommend clearing broad drains, fixing the spot or routing, improving crossfall, and if needed, resurfacing with a more permeable or drainage-friendly varying course. Overall, friction and structure are good, but drainage is the priority. That's all from me. Thank you.